My name is Fleur and I'll talk you through my project, while you can sit back and relax and enjoy some amazing footage of our fieldwork season. My research project is on the fate of organic carbon, which is released from eroding permafrost along the Canadian Beaufort Sea coast. The aim of this project is to disentangle the degradation of permafrost and to what extent sorting of sediment influences this process. Where does it come from and where does it go eventually? But let's get back to the beginning. Why do we even want to know this? We all know by now that the Arctic is rapidly changing and the rising temperature causes permafrost to melt. Erosion rates increases and reaches on some locations up to 10 meters per year. This does cause a dangerous situation for the people who are living there, but it also means that previously stored carbon is released into the atmosphere as a greenhouse gas. When permafrost erodes, material will fall, slide or drip into the ocean. As soon as this happens, a few processes takes place. This material will be sorted due to their size and density. These two properties influences the locations where this material will end up. Part of this eroded material will be suspended in a water column and part will settle down as sediment on the seafloor. However, it's unknown what type of material end up where and what material will degrade first. In order to answer this question, we will use hydrodynamic fractionation to take account for this sorting process. Okay, let's pause here for a second. Hydrodynamic fractionation. This means the separation of minerals by transport in a sedimentary system. After we sampled sediment and parent material, we will simulate this sorting process in the lab, so we can analyze these fractions separately. Okay, let's put this in perspective for a second. What if we compare this sediment to a basket of fruit? It contains apples, pears, oranges and maybe even nectarines. Previously, we looked at the mean of this fruit basket, like we put everything in the blender and make a nice smoothie. However, when I'm drinking this smoothie, I can't distinguish between my different types of fruit. When we fractionate our sediment, we are able to analyze each type of fruit separately. This way we can compare apples to apples and pears to pears. Are you still with me? Yes, okay, good. Let's finish this. As soon as we have our data on these fractions, we can see where the apples, which is in this case our organic carbon, actually ends up in the system. How fast carbon in a particular fraction will degrade and how much there is left.